In this video, you'll learn to construct an inscribed polygon. I am sure that you figured this out already, but you will need your compass and straight edge for this video. And let's go ahead and get started. First of all, what is an inscribed polygon? An inscribed polygon is going to be a polygon where each vertex of the polygon is on the circle. So let's see, a polygon. So if I were to think about or envision what this looks like in terms of a picture, I'm going to have some circle. Each vertex of my polygon is going to be on the circle, meaning that the polygon is inside the circle, hence the name inscribed polygon. All right. This, I think, is a very cool topic because hopefully after the video you'll understand how it has all sorts of exciting implications and connections to art. Maybe you could use this to design a logo. Very, very cool stuff, I think. All right, in the first example it says use your compass and straight edge to construct the regular hexagon that's inscribed in circle O. So in other words, the hexagon is going to exist inside our circle. I'm going to start out by grabbing my straight edge and just constructing or drawing any radius of the circle. So in other words, a radius, remember, will connect the center of my circle with any point on the circle. So I'm going to use my red pen, put two little red dots there. Step number 2 is to go and grab my compass and to use my compass to measure the distance between those two little red dots. Or in other words, you might say, measure the radius of my circle. And I'm taking a little while to do this, but I want to be exact. So that looks pretty good. Once I've measured the radius of that circle, I'm going to move the point of my compass to that red point on the circle. And I'm going to start by drawing some arcs. And I'm going to make each one of these arcs exactly the same length, and I'm going to do them all in red. Once I get my first arc done, I'm simply going to move the point of my compass to the spot where that red arc intersects the circle. And then I can go ahead and draw the second arc, and I'm just going to continue all the way around the circle. You're probably at this point getting this done more quickly than I am. And what this will do is it will section your circle up into 6 equal pieces, which is what we essentially want to have happen because we want this hexagon to be a regular hexagon. Once you've decided where each of those 6 vertices of your hexagon is going to be, then you simply can go ahead, grab your straight edge, and connect each one of those red points. And now there's your regular hexagon. Again, I think some really neat stuff going on here. All right, so there's your beautiful regular hexagon. Number 2 says use the compass and straight edge to construct an equilateral triangle that is inscribed in circle O. This is going to be very much the same construction that we just did, which is nice because it makes it easy for us to remember these. So once again, I'm going to go ahead and start by constructing any radius of that circle. I'll measure that distance using my compass. And again, the distance that I'm measuring is the distance between that point that's on the circle and the center of the circle, or another name for that would be the radius of my circle. And again, I want to be exact and precise in my measurements. And then once I have that measurement, I'm simply going to put the point of my compass on that point that's on the circle, and I'm going to move around the circle and construct my 6 equal arcs. And then once you have those 6 equal arcs constructed, you'll have the 6 points that divide that circle into 6 equal pieces. But for a triangle, we don't want to divide the circle into 6 equal pieces. We want to divide our circle into 3 equal parts. So instead of constructing or connecting consecutive pairs of vertices like I did with a hexagon, now I'm going to only connect every other vertex. And there's my gorgeous equilateral triangle. All right, my last construction is to construct the square that's inscribed inside the circle. This time, instead of starting by drawing a radius, you're going to start by constructing a diameter. So diameter, remember, is going to pass through the center of the circle, and its endpoints are going to be on the circle. So I'm going to focus on the line segment now that has those green endpoints. And since what I'm trying to do, in essence, to inscribe the squares, I'm trying to divide that circle up into 4 equal parts, what I'm going to do is I'm going to take that line segment that I just created, and I'm going to construct its perpendicular bisector. And hopefully this construction should feel comfortable for you, because this is one that we've done before. In fact, we've done this one quite a lot. So I just need to go something that's a little bit longer than the radius, make an arc above and beneath, flip it around and put my vertex or the point of my compass at the opposite end point of my segment. And again, another pair of arcs. And at this point, I'm done with my compass, so I'm going to go ahead and put that out of sight. And I'm going to go ahead and construct that perpendicular bisector. What I'm really looking for on this perpendicular bisector are those 2 green points where my perpendicular bisector intersects the circle. Because what that has accomplished for me is I now have the places where each of the 4 vertices of my square go on the circle. As for why this works and why it makes our square a square, we'll talk more about that when we get to the unit on circles, and that should really bring full circle, no pun intended, and enhance your understanding of this construction. But for now, the fact that you know how to construct the square is really all you need to know. All right, so up at the top of the next page, just like always, the key ideas and the important understandings, what's important for you to remember from this video, and then a little bit of practice with the constructions that you learned on the preceding page.